Welcome to The Explainer. We are jumping right into something truly fascinating today. If you've been following the transportation industry, you know we've been waiting years to see the final form of Tesla's electric behemoth. Well, the mass-production 2026 Tesla Semi finally debuted at the ACT Expo in Las Vegas, and what rolled off the line at Gigafactory Nevada surprised pretty much everyone. The biggest shock wasn't the hauling power or the battery range, nope. It was actually a deeply counterintuitive decision regarding the truck's AI and its eyes.
Right, so this brings us to the massive question hanging over the whole trucking industry right now. Why on earth would you cut 16 cameras to build a smarter truck? Think back to 8 years ago. The original prototype Semi made jaws drop because it had 26 cameras plastered all over its 72-foot frame. It was this incredibly dense observational network. But after nearly a decade of testing and racking up close to 8 million real-world miles on public roads, Tesla did something totally baffling. They stripped 16 of those cameras away. Only 10 made it onto the production model. So what happened? Did they just decide to gamble with the safety of a 40-ton vehicle to save a few bucks?
Well, absolutely not. The reality of that decision actually represents a massive breakthrough. When you compare the 2018 prototype's sprawling 26 cameras to the streamlined 10-camera AI Force system on the 2026 model, it becomes super clear this wasn't about cost-cutting. Those 8 million testing miles basically served as a rolling laboratory. And what Tesla discovered, which by the way is a breakthrough no legacy competitor has matched yet, is that sheer volume doesn't equal better autonomous driving. It's all about precise placement and optical quality. Basically, precision beats volume every single time.
Okay, so where did those remaining 10 cameras actually end up? Let's break it down. Up front, you've got 3 cameras operating kind of like an eagle's tiered vision. One looks way out, 820 feet ahead for long-range obstacles, while 2 others handle the immediate close-quarter traffic. But the absolute game changer here is the lowered side repeaters. By dropping these cameras significantly lower than they were on the prototype, Tesla completely eliminated that massive, decades-old blind spot that has always plagued traditional Class 8 trucks. For the first time, a Semi can clearly see a small car hiding right next to it. Throw in rear cameras angled specifically to help with the famously tricky job of trailer coupling, plus an internal cab camera to monitor the driver, and you've got a brilliantly optimized visual network.
Now, this specific camera layout isn't just about good visibility. It creates an enormous competitive advantage. Here is the crucial detail. These 10 cameras share the exact same hardware architecture as the AI system currently running on millions of Tesla passenger cars, the Model 3s and Model Ys. Because the architecture is identical, Tesla can take their entire neural network, which has been trained on literally billions of miles of passenger data, and transfer it directly to the Semi. Traditional truck manufacturers, they have to start from scratch. They spend years building totally bespoke AI just for heavy-duty vehicles. Tesla doesn't have to rebuild a thing. They're quite literally standing on their own shoulders.
To really wrap your head around this, think about the AI training process like this. It's exactly like teaching a student using one universally consistent, perfectly accurate textbook. To make this happen, Tesla decided that all 10 of these cameras would be manufactured exclusively by a single supplier, Samsung. This guarantees the exact same optical quality, whether it's mounted on a compact passenger car or a massive commercial truck. And why does that matter so much? Well, if the textbook is perfectly consistent, the AI student learns incredibly fast. It never gets confused by slightly different lenses, weird resolutions, or wonky color processing from a bunch of different input sources.
This uniform consistency is the absolute bedrock of a powerful AI. It gives Tesla clean, standardized data from A to Z. It completely eliminates the single largest variable in machine learning, which is input inconsistency. A Model Y and a Semi literally see the exact same road in the exact same way. This totally bypasses the deeply fragmented AI standards that legacy automakers are currently battling. I mean, those guys are dealing with different sensors from different suppliers speaking completely different visual languages. Their engineers have to spend countless hours just trying to get the sensors to talk to each other. And the scale of this standardized data collection is just mind-blowing. Let's put this into perspective. At full capacity, the Nevada Gigafactory is designed to pump out 50,000 trucks a year. Multiply those 50,000 trucks by 10 AI-4 cameras, and you are looking at 500,000 brand new cameras being deployed onto America's highways every single year. The sheer volume of data they're scooping up is staggering.
And let's be clear here. These 500,000 cameras aren't just cruising around on sunny California afternoons. They are out there collecting uniform data under the absolute harshest conditions the industry can throw at them. We are talking the scorching, paint-peeling heat of Death Valley,
sub-zero ice storms in Minnesota, heavy torrential rain in Seattle, and just the everyday constant grime at logistics depots. With every second that passes, Tesla is quietly building the largest full self-driving training dataset ever assembled for heavy-duty trucks. It's an insurmountable dataset that literally no other manufacturer has access to right now.
Now, technical specs in AI data are great, but market acceptance is what really proves the model, right? Well, in California's Clean Truck and Bus Voucher program over a recent 13-month stretch, Tesla locked in an incredible 965 applications. Meanwhile, if you take the combined giants of the traditional trucking industry, Daimler, PACCAR, and Volvo, they received fewer than 100 applications total. Just let that sink in for a second. That ratio shows absolute, undeniable market dominance from a company that had practically zero foothold in commercial trucking just 5 years ago.
So, what's driving all that market demand? A massive part of it is a brand new business model unveiled at the ACT Expo by a partner named Alith. It's called Semi-as-a-Service. This is a fully bundled package that covers the vehicle itself, all the required charging infrastructure, and the energy, all wrapped up under a single fixed monthly fee. The brilliance of this model is that it completely eliminates the massive upfront capital barrier that usually makes fleet operators totally freeze up before transitioning to electric vehicles. With this, you just pay a flat rate and get right to work. It's a total game changer.
And the financial endgame of getting all these electric trucks on the road is profound. You see, Tesla isn't just trying to sell trucks. They are selling an entire autonomous logistics ecosystem. The ultimate long-term goal here is to convert heavy-duty freight into a self-operating network, eventually replacing human drivers to create a much smarter, safer ecosystem. And the economics? They are impossible to ignore. Running a highly efficient electric Tesla Semi costs roughly 15 cents per mile in electricity in places like Texas. When you eventually automate that network, logistics become dramatically cheaper than anything operating today. And that ultimately means drastically lower shipping costs for the stuff you and I buy every single day.
Okay, but let's take a quick breather and ground this explainer with a much-needed reality check. There are still some very genuine obstacles standing in the way of this autonomous utopia. Currently, there is a total lack of federal regulatory approval for unsupervised full self-driving on Class 8 vehicles. On top of that, a lot of U.S. states still legally require a human driver to be physically present in the cab, no matter how capable the vehicle is. And frankly, some experts still have totally valid objective questions about how reliable a pure camera system is in extreme, prolonged weather, like dense fog or a massive, blinding blizzard. We still heavily need real-world data to prove the system can handle the absolute worst-case scenarios safely.
But despite those regulatory and environmental hurdles, Tesla's strategy is absolutely unshakable. They are anchoring everything on a proven philosophy: hardware first, software later. Every single Semi rolling out of Gigafactory Nevada today already carries the highest level of autonomous driving hardware. They are perfectly fine letting that hardware sit dormant for now. They're just waiting for the software to reach full maturity and waiting for legal authorization to finally catch up. And when it does, they won't need to recall or rebuild their fleet. It will simply require a single over-the-air or OTA software update to awaken the entire system.
Which really brings us to our final provocative thought for today. The traditional competitors are eventually going to try to catch up, for sure. But they're going to have to build their hardware fleets completely from scratch. Tesla already has the hardware out there on the road, actively collecting data. So when that OTA update finally drops, and tens of thousands of semi-trucks simultaneously wake up fully autonomous overnight, will the rest of the industry realize they are literally a decade too late? It's just a fascinating look at how a perfectly structured, organized approach to AI might just rewrite the entire future of transportation. Thanks so much for joining me on this explainer, and I'll see you next time.